Hey, it's Darcy McConvey, and this is the Venture and Gains podcast. The purpose of the show is to connect people to other great people, ideas, and opportunities. Everyone has less than a handful of people in their network where it seems like there's something different about them. Everything they touch seems to turn to gold, and they're those can't-miss people, and you just know it. These are the podcast guests. We catch them at various stages of their career, learn from how they think, so you can connect the dots and apply it.
Mina and his team are literally and figuratively on a rocket ship. Since meeting his co-founders in college and starting to launch rockets in his spare time, space, engineering, and big ideas have been Mina's passions, and ultimately where Kepler Communications was born. The 2015 Kepler origins include big goals like putting internet access outside of Earth, based on the premise, connectivity is the lifeblood to powering economies. Today, with 5 satellites in orbit, and a goal to have 50 by the end of 2021, Kepler is becoming the Dropbox of space, making an electric impact on the rapidly growing space economy. As people like Elon Musk and Richard Branson have made space a place that was once reserved for sci-fi stories only feel more mainstream, Mina highlights the reform of space access through business model innovations, critical government regulation changes, and how people are starting to develop the multi-trillion-dollar space market. We're thankful to have him, and here we go with Mina. Welcome back. Today we have a special guest, Mina Mitry, who we're super excited to have on the Venture and Gains podcast, really on the cutting edge of space and space exploration, where he's providing reliable and affordable access to connectivity in space. So to me, that sounds like quite the task. So Mina, welcome. Glad to have you.
Thanks for having me on board.
You bet. In an earlier conversation, you were telling me that in college, well, if I think about what most people do in college, various things, but, nights on the town and, having fun in various ways. You were telling me that in college, you started launching rockets in your spare time. So tell me a little bit more about that.
Yeah, we were pretty fortunate in my undergrad and my graduate degree to build up an not-for-profit where we got to do things like mix laughing gas, candle wax, and aluminum powder to launch our own rocket engines, take them up to a 10,000-foot altitude to do science and bring them back down to Earth. We built our own drones that would take computer vision images and recognize patterns or targets on the ground, and built our own satellites that would go up into orbit doing microbiology experiments. Not sure exactly how I got into it, if I'm completely honest. I think it was inherited early on as a small team that would create these powered aircraft that lift a lot of weight. And then we decided to expand scope, see what other things we could do. It's also where I met some of my co-founders for Kepler at the onset there.
Right.
And it was just a great breeding ground of ideas. When people had new ideas that they wanted to work on, we'd see if we could tackle it. We grew it from about 5 volunteers to over 100 and had 28 million in annual sponsorship. And it's just the nature, the type of people we got to work with.
Wow. So that's like an early indicator of what you're doing today. It's like the future, what was to come. What was your undergrad in? What'd you study?
Aerospace engineering. Yeah, so I studied aerospace engineering in my undergrad, my master's, and then I spent a little bit of time in my PhD before I left it to go work on early stage ventures.
Wow. So today you're the CEO of Kepler Communications. I remember when I first came across you, it was at the DMZ incubator, and you just struck me as a guy that, obviously you were tackling a very big problem or maybe not so much problem. Yeah, problem, but also market. And, took a lot of intellectual horsepower, takes a lot of intellectual horsepower to do so. And you seemed like you were the guy to do it. But in addition to that, you had, those CEO characteristics, at least in my view, that is a tough combination to find, which is, seems like very business savvy, great communicator, great presenter, but also this deep domain technical expertise. So it seemed like a no-brainer fit, because to be honest, thinking about the problem was way outside of sort of my domain, but you just struck me as a guy that if anyone could do it, you could do it. So where do you think the combination of that technical prowess and, the CEO type presence comes from?
Well, I don't know if I would have described myself in so many adjectives that are very flattering, but I appreciate that.
I guess that's my job. Get you pumped up, and then you can take it from there, right?
Fair enough. No, so I don't know that there's anything in specific that's an aha moment that helped me build the variety of skills that are useful to the team today. But I can definitely give a large amount of credit to running an not-for-profit. It's a little bit harder when when you're not paying people to come in and get them to do exciting work. That's really difficult, having them pull in late nights so that you can deliver on objectives that really are just for the sake of the accomplishment rather than to an end customer. So I think that helped to hone a lot of the rallying the team, building towards a unified vision and helping them see the light at the end of the tunnel. And then outside of that, really the deep domain technical expertise just came from late nights and working in a variety of different settings. At a point in time, I used to be a researcher at Pratt & Whitney Canada, working on aircraft engines and their optimization with some of my master's work. I also spent a ton of time doing research and development for the benefit of the not-for-profit. It takes a lot to build a rocket engine. Those things aren't quite easy. They don't just work out the box. So it's a lot of that domain expertise that was hard-earned through the course of the work that we did.
It's awesome. It's fascinating. I can imagine it takes a lot. I can imagine. So why don't you, we're a little ways in, give a little bit of an overview of Kepler and what you guys do and the problems or markets that you're tackling, what those might be.
Yeah, happy to. So we started Kepler in 2015 under the same founding vision that brought us all together, and that was to put up internet access outside of Earth. So if you go up into space today, there's no such thing as internet access. You don't really have a steady real-time connectivity that you can use for moving data from anything that you're doing up in space. And I'll get into why that's a big problem a little bit later on.
Sure.
So that doesn't exist today. And we know that connectivity is a bit of a lifeblood that's empowered economies here on Earth. And so we set out to build connectivity outside of Earth, but we had to do so sustainably. To get to building connectivity outside of Earth, the first step is tackling some of the underserved regions here on Earth that are out of reach of terrestrial coverage or just have really bad options today from traditional satellite communications. And what that allows us to do is put up the infrastructure that'll eventually power internet outside of Earth. And some of the applications that we serve across the board, they include maritime, they include oil and gas, they include polar regions, basically anything that traditionally didn't have access to connectivity and were providing it, or in many cases that did have access to satellite connectivity, we give them a 10 times faster data link at roughly 1/10 to 1/100th the cost of what's currently available to them. So it creates the abundance of access that they necessarily need to run major business operations.
And how does that connectivity, you said maritimes, oil and gas, and polar regions, like how does the connectivity transform? Obviously speed is important, but how does the connectivity transform their business?
Well, today a lot of businesses are moving to become digital first. And above and beyond that, they're aggregating and collecting mass amounts of data that they historically just didn't do because of inadequate access to sensors or just not a need to do the same type of work. But now businesses, say in the maritime region, are doing these massive seismic surveys. So they're mapping large areas of the sea to try and identify drilling locations for oil and gas or for research purposes. And those mass amounts of data that they're generating just don't have a great means of being sent back to HQ for processing and retasking the ship.
Gotcha. Like it seems like an incredible solution for what they need in terms of, real-time data transmission, that would strike me as an expensive, I would think that would be expensive. You're saying it could be 1/10 to 1/100th of the cost. How does that side of the equation work?
Really, when we started Kepler, we recognized one of the main problems is traditional satellite infrastructure is just built completely different. They take 3 years in design and development and then throw up a several $100 million satellite asset that's meant to operate for 15 years so that they can recoup the costs that they've put into it. But these assets, because they're meant to run for really long lifetimes, they're very low risk. And as a result, they're using technology that's extremely dated. It's physical hardware that can't rapidly be upgraded while it's been on orbit, and it's just fixed in time. What we ended up doing differently, and what's really enabled us to bring down the cost so dramatically, is we built our own proprietary software-defined radio. So that means a lot of the things that used to be done in physical hardware now can be done in software. We put them with state-of-the-art electronics and satellites that could be 1/100th the physical size, but still deliver the type of performance our customers expect of us. And the net result is we get the economics that we talk about. So our satellites now we produce them almost on a monthly basis instead of the traditional 3 years. And they're about 1/100th the cost to get out into orbit because of all of our state-of-the-art electronics and doing most of our work in software.
So how many live satellites do you have currently?
You're catching it as a good time. We've got 5 satellites in orbit today, 3 just launched in September, and we've got a major launch coming up at the later part of December.
I'm always curious, like where and how do you go about launching a satellite? Like, not to be, make light of it, but it's not like you're going in your backyard and just firing it off. Like, what's the process and who's launching them for you?
Well, launch these days has become surprisingly simple. And this is part of the tailwind we see where space access as a whole is becoming reformed. Historically, space access was something that's entirely reserved to the domain of government and quasi-government agencies because they've got to buy these massive rockets. They're only limited availability. Sometimes government regulations wouldn't allow you to even get access to space altogether.
Right.
But what's changed in recent years is quite a few different things in space. Everything from, simple business model innovations. You can share a ride into space, and historically you couldn't do that. You and I could get together and split a rocket 50-50, or we can take the equivalent of an Uber pool and launch ourselves up to space, spread across 5 other people. And that in of itself was an innovation that helped reduce access and barriers into space. So back to your question, you can buy launch pretty readily from many different resources. You can go directly to some of the governments with the rockets that they have, whether that's the Russian government and the Soyuz, or many other entities, or there are quite a few new private commercial actors. You can go to SpaceX today and buy a small fraction of the mass on their rocket. You could go to Rocket Labs in New Zealand, which is a brand new company that started in the past decade to build small rockets for launch, and it's become really accessible.
It's interesting. Like, I would, historically you're saying governments were it was a government domain, space was. I can imagine that in many respects it's still highly regulated and very much protected by governments. So how do you navigate that? Like, what are the lines between private and sort of government, and how do you navigate that? Is there any risk to your business there?
Yeah, so regulation actually is still very prevalent in space. And as you said, it's predominantly for the protection of the resource that we have, which is very finite. You have to tread a few lines to get access to space in the communications domain, and specifically, the main thing you have to worry about is spectrum and spectrum rights. Unlike cellular wireless, where spectrum is auctioned off to the highest bidder,
So just explain to me just for people what's spectrum?
You can think of spectrum as the wireless airwaves that we use for communication.
Okay.
It's similar to, I don't know, I'll use a bad analogy here, but similar to land. So if you have access to specific pieces of land, you can develop what you want on top of it. And in the same vein, for communications, if you have access to specific wireless airwaves, you can develop what type of service you want on top of it.
Gotcha.
I don't know, is that a helpful analogy?
Yeah, the land analogy I think is a good one, right? Like it's certainly a good one. So, I think I cut you off in the middle of your sequence. Just wanted to clarify spectrum.
Yes. So spectrum is one of the heavily regulated parts. The other parts of it are just orbits and the access you have to space to make sure we don't create too much space junk. And to gain access to specific spectrum, you've got to work with the United Nations, have them approve your use of the spectrum. You have to work with the Canadian government if you're from Canada, because they have to take on a large amount of liability for you launching something into space on certain frequency bands. And then you've got to work with the local governments where you intend to deliver the service. So those are all the regulatory hoops you got to jump through. Fortunately, we've gained that access over the past few years. It's taken a bit of time, but we've built up a very compelling spectrum portfolio.
Say if you launch in Canada, I know you're a Toronto-based company, but I don't think you are limited in terms of your channel partners, your partners, and where you're launching. You just said you just mentioned a few others: Australia, Russia. But so you launch a satellite in Canada, but the satellite is going to be global, is it not?
Exactly, and that's why the United Nations comes into play.
Gotcha.
Yeah, just a bit of perspective. Our satellites, they fly 575 kilometers above the surface of the Earth. It's roughly about 350 miles. They go from North Pole to South Pole in 90 minutes, and they're flying about 7.5 kilometers per second. They'll see every location on the Earth once per day, and so they're truly global in their reach.
And what's the lifespan of one of these satellites?
So the satellites will operate for upwards of 5 years.
Wow.
But really, that's more of a decision or an active decision on our part to swap out with the latest and greatest technology and put that into orbit.
So 575 kilometers orbits, they fly at 7 kilometers a second. They see every location. So what's happening? Like, who's connected to that satellite, and what's that satellite doing exactly? I think you explained it almost like a Dropbox-like scenario.
Yeah, so the long-term vision is to set up a real-time network that's moving data nonstop between Earth and space, and obviously building up that internet outside of Earth.
Mm-hmm.
With just a handful of satellites, we're tackling sort of the tip of spear applications. Those are the types of applications that, they can tolerate a delay in moving their data, but they still have a mass amount of data that they need to travel from their operating site. And that's what we use the first few satellites as drop boxes in space. So they can upload data directly onto the satellite. It gets downloaded back to their operations center where they can process it, but it takes a few hours to get there.
So space itself is, in some ways like sci-fi to some people. I think a guy like Elon Musk has made it more mainstream, but like, how do you see the awareness of space, and then not the investment opportunity necessarily, but just like it becoming more mainstream and more broadly recognized? It's funny. I watched, it's a bit ridiculous, but an interview with the Winklevoss brothers on Barstool Sports. And it was funny because they try to explain the value of Bitcoin. They've done obviously really well in cryptocurrency and Bitcoin. And they started talking about why, it has a greater store of value and serves a purpose better than gold, because gold is no longer a limited resource, because a guy like Elon Musk is going to Mars to mine for gold. So you hear stuff like that and you're just like, what are they talking about? So, not to be light about it, but how is sort of the profile of space and space related businesses changing in sort of in the market, or in the broader context of people's awareness?
Well, space, like I mentioned earlier, is becoming very mainstream today. Historically, it's been a government or quasi-government agency-led or resource that's been used. But now we're seeing the first space IPOs that are happening. If you take a look at Virgin Orbit, which is looking to build the space tourism business, you can go up into orbit, fly around, and buy a tour ride ticket to observe space like an astronaut might. They've gone public. We are also recently seeing the announcement of another space transportation business called Momentous. They're going public early 2021. And so we're seeing the tailwind of space becoming more accessible, directly leading into new opportunities that are now mainstream. It's pretty incredible to think, we're talking about space tourism here and now.
It's wild to think about, actually. So, you indicated that I think by 2040, space is going to be a multi-trillion-dollar market. And so how does Kepler, obviously what you're doing, but think about capitalizing on this sort of frontier economy?
So actually, it's a little bit more aggressive growth than what you're describing here. So space as a market, and let me just pull up the exact values here.
That'd be great.
So the space economy today is 415 billion. It's expected to grow to 1.4 trillion by 2030.
Wow.
And so really Kepler's play in the space market opportunity is becoming a software-defined satellite network. So that enables us to serve a wide variety of applications here on Earth by upgrading our network and software, and eventually becoming the satellite communications link for the space economy that provides them real-time connectivity between Earth and space on the same network.
And what's the competitive sort of landscape like for companies similar to you? Because I can imagine, you're talking about sort of not letting it get too, I think you said junky or clunky in space. You're going to see more and more related type businesses. So what's the competitive landscape like today for you guys?
Well, today I think there's quite a few players that are going out in the market looking to offer some form of connectivity from orbit to Earth. I think what really differentiates Kepler is a few different things. One is our own proprietary and owned spectrum rights, and that really creates defensibility, both now and very long term into the future, just because spectrum is a very finite resource. And then we also have our proprietary software-defined radio, and last but not least, we're vertically integrated. So what that allows us to do is have very fine-tuned control of when and how to launch and put up satellite capacity for a tight coupling between supply and demand.
So you've got 5 satellites today. Where do you anticipate being a year from now?
In about a year from now, we'll have close to 50 satellites in operation that are delivering service all across the world in space.
And how many people are part of this team delivering this? It's a monumental effort here.
Well, you'd be surprised. I think the way space gets built today is very different than the historical paradigm. But our team is only 70 people today. It'll be closer to 80 before the end of the year. And next year, we'll roughly double in size to continue to pair with our growth and the demands of our network.
That seems actually like a pretty big team, bigger than I actually would have thought. So on that note, building a team, you're tasked with a lot, I'm sure, but how do you fund, where's the funding coming from to, fund a 70-person team plus the R&D plus the manufacturing. So maybe talk to me a little bit more about the funding and sort of your roadmap.
Yeah, for sure. So maybe to clarify something, for the cost of building a SaaS business, you can build a space company. That's really what we've proven to be true here through the course of Kepler's life. But we're a traditional venture-backed business. We raised our seed round of capital in 2016, which was about 5.5 million US. We raised our Series A round of capital in 2018, which was 16.5 million US, and we'll be looking to raise another round of capital that will put us on our way to deliver the next 50 satellites in our network and continue to grow our revenue base. But one of the things that's been unique about Kepler, and something not historically true of satellites, is we're able to generate revenue with just the first few satellites on orbit. Where normally for satellite networks, they take if you build it, they will come approach, building the entire network before they can turn on any part of revenue on the network.
So in some ways, it's a lean version of what it has been, very lean.
Yeah, certainly you can say that. We've even seen in the most recent years companies repeating the same mistakes, just building on if you build it, they will come approach, investing a few $100 million before ultimately going bankrupt because the demand isn't tightly coupled with the supply.
Right. So when you look at funding partners, I'm sure at this point it's very strategic in terms of, who's going to be in your next round and why. What's the landscape like for sort of the type of investors that you have or are looking for from a strategic perspective?
A lot of our investors are pure play financial investors. So they don't have a particular bend or strategic avenue towards the specific business. They're financial investors because they see the very compelling returns that come of working in a space business and the type of very unique infrastructure that you can get out of it that no one else in the world would have. And that's historically shown to create great returns. So in our future rounds of financing, we'll be looking for traditional venture type investors that are interested or have a mission alignment for what we want to build long term and recognize the compelling value that gets created from building something that few people in the world have access to.
So it doesn't necessarily have to be strategic because it sounds like it's more just, traditional type VC that sees the vision, sees the market, sees the people and wants to, be a part of that.
Exactly.
So why don't we flip over to, I don't know why I think this is interesting, but maybe you can help me understand is I think it's great that you manufacture your satellites in Toronto, correct?
Yeah, we do everything in downtown Toronto, right at Spadina and Queen.
Like to me, that seems a little unique, but I guess the cost to manufacture for you guys is relatively low. So it's a way that you can kind of, create a product close to home.
Well, the cost to manufacture isn't driven by labor by any means. The cost to manufacture is really driven by the type of electronics that we're buying or the types of electronics that we're building. A very small portion of that is actually the team to do a lot of work because what we've done is we've set up a lot of processes for producing our satellites at scale.
And so I guess talk to me a little bit about growing the business in itself. Like how's the day-to-day running of the business different from growing it, like being in the business versus working in the business versus working on the business? There's certain things that have been much harder or easier than you anticipated.
I think you put it well. So that there's two types of mode I usually end up operating in, which is working on the business versus working in the business. Working in the business is a little bit, it's the easier set of tasks. It's running operations, making sure the teams have good communication, ensuring that there's no tasks that are being missed and we're all well aligned to deliver on our objectives. So working on the business is definitely what consumes a lot of brain power. It's really trying to figure out what's the next step, what makes most sense for us to grow, where should we be investing our efforts. So That I'd say it takes a lot of counsel, a really great board to support, a really good set of mentors, and just always questioning your critical assumptions. What is it that I know about to be factually true? What assumptions am I making?
And so when you think about sort of working, growing the business in itself, like what do you want people to think about Kepler, and how does that sort of translate into how you recruit generally? Because I'm guessing you're almost filling very specific roles as you go, but maybe talk a little bit about that.
So when we hire for growth, the most important things for us are just a deep passion for the mission that we're building in Kepler. That's by far been one of the most important leading indicators of success, and people that align well with the type of ambitions we've built in the business. One of the core values we carry at Kepler is endeavoring for the 10x. And what that means is, no matter what your art may be, whether your art is financial modeling or a type of radio frequency engineering, we want you to be the master of that art. And that's something that we value very deeply. And so that's the type of personality we tend to attract at Kepler.
Would you say endeavoring the 10x?
Endeavor for the 10x.
Endeavor for the 10x. That's great. As I think about sort of you growing your top line and growing revenue, I feel like business development would be quite interesting in what you do. So I know you've referred historically to working closely with a number of channel partners. So what does that look like, and who might those channel partners be, or just give an example of the type of channel partner that you'd be referring to?
Yeah, so in our industry, we call them service providers or value-added retailers. They're not strictly channel partners in the traditional sense. What service providers might do, and we're certainly a friend of the service provider because they bring a tremendous amount of value to the end user, the end application. There's someone that, say, works exclusively for the maritime domain, like Marlink, and they aggregate and provide solutions that are specific to maritime, whether that includes third-party services, software, physical hardware, all that's required to deliver an end solution to the maritime domain. And if we were to try and do some of that work, it wouldn't be very scalable just because it's specific to each segment or market segment that we tackle. And there's a heavy lift that's required there. But our service providers and value-added retailers, they go out and they package a solution to a lot of these end domains, and we provide the same layer of connectivity across the board. But what that allows us to do is keep a relatively lean sales and marketing team, but we build up a larger customer success team to make sure that our end service providers and their users are really happy and enjoying the work that they get out of our service. Yeah, so we try to own a lot of the customer experience through the board, and then we lean on our service providers and value-added retailers to help us scale the number and types of deployments that use our service.
It makes sense that you guys want to own the experience because the buck ultimately stops with you. So that's logical. So an example could be like a telecom, in essence, I'm guessing, right? That could sort of repackage your services, or.
Exactly. So I think I alluded to one called Marlink. It's not a broadly known name, but it is an exclusive maritime service provider.
Gotcha.
So they really go out and deliver on the needs of maritime. And there's quite a few more. They all look to serve what are enterprise users. And it's very different from, call it broadband, where you have generic requirements. You can go directly to the consumer and give them a generalized product. A lot of these enterprise customers have specialized needs in terms of hardware, software, and physical products.
It's fascinating. So if you were to look back kind of where you started in 15, I guess it was, to where you are today, has it rolled out according to plan? And it's, to me, it sounds like it's probably gone bang on plan. And is there anything that kind of like are moments in time that kind of make you happy, or like are those pivotal moments that you look back on as key to where you've gotten and where you're going?
So obviously everything looks like it's gone according to plan in
hindsight.
But in hindsight, but in practical reality, no, we've had a tremendous amount of, trialing periods to get us where we are today. So it's not been an easy route, but we're certainly on the up and to the right direction. Some of the happiest moments I can think of was the launch of our first satellite back in 2018, and hearing the first ping that came up to show us that it had worked as a pretty inspiring moment where we'd gone from paper design to operating something into orbit within 12 months. And that's something that hasn't been historically done before in the industry, and really showed that we had the right team and momentum to get to where we needed to be. And then, leading up to the most recent, where we've vertically integrated the development of all of our satellites, having our first customers sign on and using the service and then renew their contracts because they thought they had a great experience. A lot of those things were little wins that are that ring true in my mind today.
I was thinking about that first satellite. That must have been amazing. Like when you could see like celebrating. It's like when NASA launches and, they celebrate the good ones. But I could imagine that must have been such a cool feeling, such a thrilling moment for the whole team, right? Like it's awesome. So is there anything else that, that you can think of before we sort of wind up? I have a curious sort of final closing question, but before we get there, that you kind of want to highlight about Kepler, about, maybe your growth path, or people that, would know very little about sort of the space, quote unquote, that you operate in, that you'd love to sort of share?
Yeah, and if anything, that's a great concluding thought for people to take home is space has become a lot more mainstream today. It's gone out of the domain of government or quasi-government agencies, and now we're seeing those tailwinds really accelerate the work that we're doing, and bringing connectivity outside of Earth. So it's just an exciting time to be in space, and it's indicative by the massive growth we're seeing.
That's great. So my final question, and again, is a bit of a quirky one for all guests, is if you could pick one song to sing karaoke to, what would it be?
Right now, it would be this wonderful humming noise in the background.
It's not an easy one to answer. It's tough.
I'd have to say, I'm just trying to follow by myself time to look up the songs we used to sing in karaoke at the engineering bar at U of T.
That works. To be honest, and someone asked me, I'd have a hard time. So I've prepared just in case someone refires it back at me, that question.
Okay, why don't we start there? I'll refire it back at you.
I would always say the easiest karaoke song I think to sing for anybody in at least maybe my generation, because it's not, the words are easy and you don't need to carry a very compelling note, is Bare Naked Ladies, If I Had $1 Million. Anyone can nail that.
Yeah, okay.
But if I wanted to get a little more rowdy, I'd probably just throw on, like, there's probably a handful of AC/DC songs that could make that could get exciting for the crowd.
Yeah, to stay true to engineering days, I'd have to say Bohemian Rhapsody.
Nice.
That would definitely be the karaoke song.
Nice. I like that. All right. Well, Mina, it's been great. Your story's incredible. I've watched the journey from afar, and obviously going to stay closely tuned in to how it goes going forward. And it seems like you guys are you're on a rocket ship, literally on the right path. So all the best to you and your team, and thanks so much for your time, and good luck.
No, thanks for having me.
All right. Take it easy. Thanks.
Your time is valuable, so thanks for joining us for this episode of Venture and Gains, where we connect great people, ideas, and opportunities. It's this idea of net weaving versus networking. Remember that you can find more episodes at ventureandgains.com. And if you know any entrepreneurs, emerging asset managers, or fascinating people that you think would be a good fit, flip us a note and let us know. Stay well.
Darcy McConvey is a director of private capital markets at Greybrook Realty Partners and is registered under Greybrook Securities, Inc. The opinions and statements expressed by Darcy and the Venture and Gains guests are their own, and they do not reflect the opinions of Greybrook Realty Partners or Greybrook Securities. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. For investment decisions.